An in-depth look at a line, Lesson 1. My name is Barry Kimball. Overview. This lesson will demonstrate how to use the Align tool to establish continuity between two surfaces. Understand the geometry types acceptable for alignment, when and how to set up an edge alignment between two surfaces, utilizing the explicit control and positional influence options to optimize the alignment results. In this lesson, we'll cover how to analyze and establish positional alignment between two surfaces. The key learning objectives are understanding the types of geometry that can be aligned, how to analyze continuity, setting up the alignment, using the positional influence slider, and adjusting explicit control. To begin this lesson, I'd like to discuss the types of geometry that can be aligned. Natural surface boundaries or free curves can be used as input. A natural surface boundary is an untrimmed surface boundary. This is an untrimmed surface boundary, so the system will allow me to align this surface to this surface. This is also a natural surface boundary. It is not a trimmed boundary. But when I try to select that boundary, the software will not allow me to select it because this surface is trimmed on this edge. So the system or the software considers this a trimmed surface, and I would need to untrim it to align it. I can also align a natural surface boundary to a trimmed surface boundary. I can align a free curve to a free curve, and by free curve I mean a curve that is not a curve on surface. Currently, curves on surface cannot be aligned. I can also align a curve to a surface edge. In addition, I can align a surface edge to a curve, and I could align, if I turn a patch precision line on, so a U or V line on, I could align a curve to a patch precision line, or a free surface boundary to a patch precision line. Now that we understand the types of geometry that can be aligned, I'd like to discuss the construction options and the surface continuity checker before we begin to discuss the align function. The construction options and the surface continuity checker can be used to help understand how the align function works. Under tolerances, continuity, there's a number of values for gap and angle and curvature. These numbers are the values that the software uses to establish continuity when it's creating geometry, or establish continuity when you're modifying geometry, like when we're going to use the align function. So these are the values that the software tries to achieve. They're also the values that the surface continuity checker uses to determine if there is valid continuity or not. We're going to be using 0.001 for the maximum gap. The angle and curvature we'll talk about later, so those aren't that important to us right now. And under fitting, there's an option that I'd like to point out called curve fit checkpoints. It's set to 10. I'll explain what that number means right now. Under evaluate continuity, surface continuity, we have a gap checker, and we can check for position, tangency, or curvature. We're going to be checking for positional continuity, and we're going to be using a number of checks per span. So in the case of this geometry, we have a Bezier edge, so that's one span, so it will be checked 10 times. 10 times the number of checks, that comes from the checkpoint value. So at a minimum, the software will check it 10 times. The software can add in more checks based on some other values in the construction options that you should just leave at the default, but just know that a minimum number is 10, and the software can add in more if it sees more curvature and other things. So we'll hit go and select this boundary, and it shows us the continuity. Now, since the continuity is not within the construction options, the checker shows up in yellow. I'd like to, and it shows the distance of 2.25. But I'd like to show you a couple options that help me better understand, and hopefully help you better understand what that gap means, and make it a little easier to understand. So I'll delete that and bring up the continuity checker again, and I'm going to turn on Show Edge Labels and Show Comb. And the Show Comb brings up an auto scale option that I usually turn off. You can turn it on. It's just a base. It's a value for the height of the comb that I'll show in just 1 second. So I'll hit go, select the boundary again, and you can see that now we get a graphical representation of the gap, and we get a series of points along the line, along the boundary. Those are the checkpoints, so that's the places where it got checked. So with the left mouse button, I can change the scale of that comb, and that's what the auto scale would affect. And with the middle mouse button, by sliding it to the right, I can increase the number of checks, and to the left I can decrease the number of checks. And if I decrease the number of checks all the way to the minimum, which as a user I can reduce that to 2, one at each end, it appears that this is continuous. So that's why the software is set at 10 as a minimum. So I can increase that number, and it goes to here 3, 4, 5 and on up to whatever I want. I usually increase it a little bit just to make a smoother comb, and set the scale to something that looks easy to understand. If we zoom in, the checkpoints are these little dots. So that's what show edge labels are. They're little dots along here that show where each point has been checked. Okay. All right. I'll delete that locator, and we can move on to the actual align function. Now that we understand the continuity checker, we can discuss the align function and how to repair those continuity errors. In this case, we have two natural surface boundaries that we'd like to have a 0 gap. I've determined that I like the layout of these control vertices, so I'd like to modify this surface to match this surface's boundary. The left mouse button, when selected on a boundary, will bring up the pick chooser. So by moving up and down, I can tell the software which surface I'd like to modify. So I'd like to modify this surface, so I'll release on the left mouse button. You need to select the surface that you want to modify first in the align function. Second, by clicking again, the surface I want to match to or align to. In this case, the software has added in quite a few spans to achieve continuity. And the reason for that, at the default settings, it's trying to keep the original boundary in its same shape. So keep the positions of those in kind of 3D, almost the same, but move them as little as possible to achieve continuity, but get as close in continuity as it can get. When it does not achieve continuity, based on the construction options, it begins to add in spans until it achieves continuity. Most users at this point would select the explicit control option, and it's set to 5, and you can see that the gap has been reduced from 2.25 to 0.32, so about 2 millimeters closer. And if we look at that gap, it varies all the way along on this little comb. But you can see that the control vertices are basically in the same locations as before. They've just been moved in and out and up and down as little as possible to achieve continuity. We could increase the degree to 6 in the v direction, and the gap does go down. 7, it continues. And we could keep adding in degree until we try and match continuity. What the software did is it added spans until it achieved continuity. And neither of those seem really like the result that we want. In this case, when it's two natural boundaries, explicit control isn't really the proper solution. The positional influence is what's having an effect in this situation. Now, the positional influence being set to 0 tells the software that it's user-controlled CV position. So I'd like the software to keep the CVs in as close to their current position as possible, or layout as possible is a better way to phrase it, and increase spans until you match or align. As we slide this slider over, you can see you get fewer spans. If I go back, you'll see the spans increase, and we go to halfway. Now we're moving towards telling the software that it can be in control of the CV location. So we move a little more, you get a little more movement in the CVs, and if we go all the way to 1, that's system control. So now the system is in total control of where the control vertices are, and it puts them spot on point to point. And you can see once again our 10 checkpoints shown here. Okay, so a value of 1 indicates the software is in control of where the control vertices will be, and a positional influence of 0 means the user is in control of where the CVs would be. Okay. The next set of surfaces I'd like to show are a trimmed surface here and a natural surface boundary. So just to show that this is in fact a trimmed surface, I'll show you the control vertices here. I'll turn those back off, and we'll open the align function. Before I make this alignment, I'd like to point out that this isn't my preferred method. In this case, I would most likely untrim the trimmed surface and align by projection, but you can align an edge to a trim edge, and there's some nuances to doing that, so I'd like to show those now. So I'm going to turn a continuity checker on here for position. You can see we have a 0.02 gap, a little bit right around that area. It's okay over here. So if we wanted to repair that gap and not do any untrimming, see if we can just fix that. That's a nice job for the align function. Left mouse button on this boundary, and I'm not getting a pick chooser. So if I release the left mouse button, it selects one of the boundaries. Well, it's selecting the natural surface boundary because the trim boundary is not valid for input. So if I make another selection, it shows me that it's established the alignment and it's added 1 span. So in this case, since it's not a natural boundary, it's a trim edge, I might want to try the explicit control feature. And that doesn't seem to be getting me the continuity that I want. We're at degree 6, it's 0.002. So I'm going to try the positional influence slider a little bit. And as I move it, you can see it starting to move the CVs to the right. And at about 0.4 we get continuity. So I want as little a movement in these CVs as I need. I don't just want to go to 1, let's say, because I might not get the alignment that or I might not have the shape that I want still, since it's a trim edge, not a natural surface boundary. Okay. One thing I'd like to point out with the slider, well, where is enough movement in this slider? Because I want the minimum amount, and it's somewhere in there. Okay, so I'm going to close this, and we'll turn on the preferences performance options, and I'll turn the construction history to update during transformation. So I have this on for the most part all the time when I'm modeling, and I'll show you why. If I query edit and select this surface, it brings up the history. Now instead of moving this and then seeing what happens to the alignment, as I move it, the construction history updates. So as I move to the left, it goes back to 0, and as I move to the right, you can see the numbers on the continuity checker are moving, and they're getting better, and I can move it just enough so that it gets the continuity without moving the CVs too far. Okay? That's the positional influence slider. Okay, in addition to checking for positional continuity, I'd like to show that we can specify the continuity check. So we've used our positional influence slider to get continuity. We need curvature continuity, so rather than just switching the continuity to be curvature, right now the continuity is position, so with the continuity checker turned on here, it's checking for position. But I can also specify a different level of check. By holding this button down, we get the tangency or the curvature. So I could check this for tangency and check it for curvature. So this boundary is curvature continuous without any modifications to the tangent and curvature rows. That's not always going to be the case, but sometimes it may be, and I like to modify the surfaces as little as possible. If they don't need to be modified, I don't modify them. So that's the specify continuity check and the align tool. In this lesson you learned what geometry types can be aligned, how to set up and establish positional continuity between surfaces, and how to efficiently use the positional influence and explicit control options.